Alright guys, I'm back here to show you how to do another practice problem involving neutralization reactions, involving a strong acid and a very weak base. Now this problem is a little unique because it does not contain a hydroxide for its base. There isn't a hydroxide, meaning an OH. Now that presents a problem. If there is no hydroxides present on the base, we cannot produce water in this reaction. Okay, so that's how this problem is going to differ. So let's go ahead and get started. First thing you need to do is write down the reactants. We have NH3 and we have HNO3. So we've got ammonia and we've got nitric acid. Now, if you look, you know that this is a strong acid. This is the weak base. Now, on these that do not contain hydroxides, I never break them down into ions, because that helps in the understanding of what's going on as far as in my scratch work, to help me understand what my product or my products are going to be. Alright, so let me go ahead and work this one. You can see what I'm talking about, I hope. Okay, now on my scratch work, I'm going to go ahead and dissociate my strong acid. I know it's going to break down into H+1 and NO3 -1, because that's the ions of nitric acid. H is +1, it's in column number 1. NO3 is on the back of your periodic table that you can get off the website, is a -1. Now, this ammonia here doesn't have a hydroxide. Now, what I do in my scratch work is, since it does not contain a hydroxide ions, I do not break it down into ions, meaning I don't even show it's got a charge or anything. I don't even show its lone pair or anything. I just write down NH3 again. Now what I do is make sure that I clarify the behavior of this acid and its ions when it hits the water. Okay. Now what happens here is this hydrogen ion, or this proton, being the acid, wants to donate its hydrogen to the base, because acids are proton donors and bases are proton acceptors, meaning acids donate hydrogens, bases accept hydrogens. So what I do is I always circle the H+1, this is my scratch work, and I show it going to these other hydrogens on the base. This always works too, as far as getting your thought process together of writing these. So basically what's going to happen is this NH3 changes itself to NH4. Now that looks familiar. That's because NH4 is really close to NH4+1, which is an ion. Now that's an ammonium ion, because if we add this extra hydrogen to it, we increase the count from 3 to 4, and we pick up an extra charge of +1. That's where this +1 came from. Now when we do this, we're leaving behind the NO3, so that gives us NO3 -1. Now remember, in chemistry, opposites attract, so these will come together and make ammonium nitrate. That's NH4 NO3 written together, because the one goes down behind the 3 and the one goes down behind the 4. And if you remember from the simple rules that I've taught you, don't write ones at all. Okay, so this is our scratch work. So we've got our ideas together and we've got our complete written up here. Now let's write it down here so we've got it all in order. Okay, my complete, this is what I would write as far as my answer is on a test or to give to the teacher. And this is what I want you to give to me. I want you to write NH3 plus HNO3 yields NH4NO3. Now, from this, You can check and make sure but it's balanced, but it is. From here you can write down the ionic. Okay. Now remember, do not dissociate weak acids or weak bases. So you just write down the NH3 again. Now this is a strong acid, so you must dissociate it. So that gives you H plus 1 and NO3 negative 1. Yields. Now this thing is soluble, so you have to break it down to ions. Whoa, that's crazy, but you have to because it's soluble according to the solubility rules. Okay, so all of that scratch work up there that I've written down to get my thoughts together helped me get this one right. Now remember, you got to cancel out the spectator ions before you can write down the net. Now if you look closely, NO3 is the only one that appears on both sides. Therefore that's the only spectator you have. So the net ionic equation would be what's left behind that you didn't mark out. NH3 plus H plus 1 yields NH4 plus 1, and you're done. Just remember, if they ask you about the spectator ions, make sure that you know it is NO3 negative 1. Now that's how you do one that contains a weak base that doesn't have a hydroxide on it. You can't make water, so you're usually almost always going to have one product. That's a big hint. One product. Okay, if you remember that little cheat sheet part of doing this, you know, shortcut, whatever you want to call it, that will help you do these problems. Alright guys, I hope this helps. Just watch it a few times and you'll have it down pat. Just remember, no hydroxides here, so you can't make water. You can't break weaks down, so don't break them into ions at all down here, and you'll be fine. Okay?